Welcome all. In this lecture, we will discuss about the method of finding transfer function by block diagram reduction. So consider the example, this block diagram. So we have to find the transfer function y of s by r of s using the method of block diagram reduction. So we have to use the basic block diagram algebra, the series, parallel, feedback connection, shifting of summing point, shifting of takeoff point, and like we have to follow the steps, and we have to reduce the complex block diagram to a single block, so we can easily find y of s by r of s. That is the method of block diagram reduction for finding transfer function. So we can start. So if you are looking here, so this g1 and g2, so this g1 and g2 are like this, a series connection. So this can be replaced. We explained that it can be replaced by a single having value, a single block having value g1 of s into g2 of s. So here the values are g1 and g2, so it can be replaced by a single g1 g2. So this is reduced. So next we can focus on this. Now this is reduced, these two blocks are reduced into one. Next we can have this one. So here if you are looking here, these two are parallel, this g3 g4, this input and this at a summing point, so it is a parallel connection like this. So the equation is we can reduce into a single block. We can replace this whole thing by a symbol one block. Value is g1 of s plus g2 of s. So here the value is g3 plus g4, so we can reduce into a single block here. All others will be fixed, same, only this will be changing. This become g3 plus g4 according to this equation. And again now this is one. So next one is this one. It is a symbol feedback loop, so it is similar to this one, plus here minus here, so it is a negative feedback. G of s is here it is g1 into g2, instead of g of s it is g1 g2. H of s instead it is h1. So the equation is g of s divided by 1 plus g of s into h of s. So here it is g of s is g1 g2 and h of s is h1, so it become g1 g2 by 1 plus g is gh is the formula. Okay, so g1 g2 into h1. Okay, so this same feedback is reduced into a single block. Next is we have to shift this shifting point. We cannot do anything other than this, so we can shift this into this side. So it is a similar to a shifting like this. Now the shifting this shifting takeoff point is before this g5 block, so it is like this. So we have to do this. We have to make after this block, after this g5. So what we can do is this is the thing, this is the connection. So for that connection we have to multiply by 1 by g of s. So we have to do a division of g5 by g5. So here already there is h2, so it become h2 by 5. So this become here, this connected, this point can be shifted to this side, but this block has to be, this value has to be divided here, h2 by 5, 1 by, if there is no we can directly multiply by 1 by gf. So 1 by gf5 into h2 is h2 by g5, so it become like this. So if you are looking here, now there is a feedback here, sorry, it is a series connection, two blocks connected in series. So again we can use a series connection, so it become this multiplication of g3 plus g4 into g5. Next there is a feedback connection. So here there should be noted that this feedback is negative here. Okay, arrow mark is from here. Okay, it is a feedback. Okay. Should be noted like that to be so g of s means not in the upper side, it is flowing in forward direction. Arrow mark is in this direction, g of s, and feedback is in this direction, okay, in negative, okay, towards the reverse direction. So here g of s is this term g3 plus g4 into g5, and h of s is h3. So the equation is g of s by 1 plus g of s into h of s. So it become g3 g4 into g5 divided by 1 plus g3 g4 into g5 into h3. Since it is minus, so plus here, since it is minus here. Then it is reduced to a single block here. So again these two are in series, so we can have a single block. Simply multiply these two, numerator and denominator. So finally it become a simple feedback. So we can have this g of s is this whole term, and h of s is this h2 by g5. So we can have the equation g of s, this term divided by, so here it is plus, so it become 1 minus. So g of s divided by 1 minus this term into h2 by g5. So it become like this by reducing. The equation is g of s, this is g of s divided by 1, this is plus here, so we have to take minus, 1 minus this term into h2 by h5. We can make this as here. So this is the transfer function. Now it is a single block, so we can directly write the transfer function, this term, whole term. So that is the example how we can find the transfer function by using block diagram reduction. We have to simply follow the steps, possible block diagram reductions, either series, parallel, feedback, shifting of summing point or shifting of takeoff point, like that, and we have to arrive at a single block. Then we can directly write y of s by r of s. So with this we can wind up the session. Thank you.